Okay, so we are now looking at the assignment. Okay, so starting from question 1, for those who joined the class, the previous class that we have had, we are not going to look at question number 4 and 5, because question 4 and 5 has been explained. So question 5 is another question we'll look at. So here we want to look at two questions. That is question 5, a different question type, question 5, and then we also look at question number 1. Of course, we can also discuss somehow here on question 3, although question 3 was on a theoretical part. So we are going to do question number 1, which is on an index numbers. Okay. So looking at index numbers, this is what this question was all about, which is question number 1 for DMT BBA 230. All right. So on the first one, there are considerations that we look at as we are looking at index numbers. Okay. So the first consideration is the purpose of an index number. So yeah, the purpose of an index number, that is the first one. So here we look at considerations. Okay. Considerations number 1. So we quickly look at considerations, then we do question 1 in detail, and we go to question 2. Okay. Then question 5. So considerations number 1, we look at the purpose of an index number. So the first one, you look at the purpose. Okay, so here we have the purpose of index number. Okay, so of an index number. Then we have the other one, which is the selection of items for inclusion. So selection, okay, the selection of items for inclusion. Then selection of appropriate weights. So these are considerations, please. So we'll quickly look at, so number 3, selection of base year. So selection of base year. Then the fourth one, selection of appropriate weights. So selection, okay, of appropriate weights. Okay, so this is what we actually consider as we look at index numbers. So these are considerations, please. All right, now we're getting down to the question now. So question here we are now looking at, where we are saying we have Zambian Indigenous cafeteria as 5 food 3-course meals to accompany any main meal. The prices P of buying these ingredients and quantity Q are given below. Okay, so we have the first one. Using 2022 as a base period, calculate the following price indices. The last buyers indices, the per share index, then we have the Fisher index. So there are these 3 index numbers that we are supposed to actually look at as we consider index numbers. Then here we're finding the volume indices. So for volume indices, it's a total different formula that we are going to use for this one, so that we get the full marks for question 1. So quickly, let us start looking at the solution. So we are using 2022 as a base period. Okay. So as the previous period, So that's what we are looking at. So getting down the solution here, the Spies index formula is given by this. Okay, so summation of P1 QO over summation of PO QO multiplied by 100%. This is only how you get to the Spies index. All right, so we are using best period as 2022. So meaning the QO will be that of 2022. So this one is for 2022 at this time, so 2022. Then this one is for 2021. Okay, it's more recent. That's what they're saying, that we're using. Even here, this one is for 2022. Okay, and then we have this other one is also for 2022. So this is about what we are doing here as we are looking at these ones. So here we can multiply to find the first one there, multiplication of these. So we are using the product. So this is just the product of what we are getting. All right. So here we are getting the product of these ones. So meaning the total figure is 2098.7926, 2135.3827. This is it only how we are getting to the figures here. So we can substitute here to get P1, summation of P1 QO. All right, summation of P1 QO over the summation of the other one, which is POQO. So here we are getting 98.28. That is the last Spies index. Then we're getting down to the partial index, is summation of P1 Q1 over summation of POQ1 times 100. So here we are using here P1, this is for 2021. So 2021, because they're saying you are using 2022 as a base period. So meaning this P1 is for 2021 and the Q1 is also for 2021. So this is how we are getting this. The PO in this case is for 2022 as a base period at this time. So 2022 and the Q1 is for 2021. That's what it means here. All right. So we are getting these ones. So as we substitute here, we'll be able to get the values that are appropriate that we need. Okay, so we are going to have the summation. Okay, so here summation, okay, of P1 QO is 275. When multiplying this one by that, we are getting that figure. This one by that, we are getting that figure. Then this one by that, we are getting that figure. Are people following so far? All right. So we go to the other one. Okay. So we go to the other one. So we are saying the other one is so meaning, well, after multiplying the P1 and Q1, we are getting that figure. Then the POQ1, we are getting the 278. So the partial index, we are getting 275.86 over that with 99.134. The Fisher index, the last one on this one is just the square root of the partial index and the last Spies index. So the square root of those are the ones that give us the values for the Fisher index. So Fisher index, we are simply saying it is the product of the Spies index and the partial index, where we are getting 98.70. Okay, 706. Okay, so we are on this Fisher index. Okay, unless there are questions so far. So that's the square root of the last price index and the partial index. So we're getting 98.706. So we have just follow, pay attention to details. Where they're saying in question A, they are saying we are using in 2022 as a base year or a base period. So this is the reason why we are supposed to pay extra attention to details so that we don't make mistakes as we are looking at this kind of equation. All right, so getting down to part B of the question. So part B of the question is now requiring us to find the quantity index using the 2021 as base year. The volume indices are calculated as follows. So the formula for last price volume index is summation of Q1 PO over summation of QO PO multiplied by 100 using 2021 as base year. So meaning this one quantity, meaning this is for 2022, all right, which is the current. And then this one, we are using the base period as 2021. So meaning this one is for 2021. So you're getting this one as 2021. Even this other one we're getting is as 2021. All right, so 2021. Then we are finding the product here. What is what we are getting? 275.86. All right, this is only getting the value. Okay, the value as we getting down to the last price index. So meaning the total of these is giving us the 275.86. Then this other one is 2098.79. Okay, after multiplying the Q1 and PO. All right, that is the formula here for the quantity index or the volume index. We have this one, Q1 PO over QO PO by 100. So meaning we are getting 760.818. This is the last price index. Okay. Now getting down to the partial index, the formula for partial quantity index or volume index is equal to summation of Q1 P1 then over summation of QO P1 by 100%. So we can find the Q1 P1. Q1 is for 2022 because we're using 2021 as a base period. So we can quickly substitute and then get the values as they come. And so yeah, so meaning that for this one, we are going to have for the partial index, the Q1 P1 is giving us 2001.35.3827. That is on the summation of Q1 P1. All right. Then we actually find the other one, QO P1. So this is for the base. P1 is for the current, which is 2022. Then we are getting 278.27 on the summation of QO P1. So meaning that our partial index, quantity index here or volume index. So this is for the volume. So for the volume index, we are going to now say we should get down to this formula here, where we are simply saying summation of Q1 P1 or summation of QO P1 by 100. So substituting in these ones, we are getting 767.3779. So this is it, the partial volume index. So partial volume index of 767.3779. So this is on the partial quantity of volume index as we are looking at the index numbers. Okay, so that is it on the question where we are saying part B of the question, then using 2021 as a base year, calculate the following volume indexes. So we have gotten the volume indexes here using 2021 as the base year. All right. Now, this answers question 1. Okay, part 1 of the question answers the first question, question 1 of this assignment paper. Unless there are any questions so far for all those who may want to ask questions.
Yes, I have a question.
Yes, please. Yes. Yes, we can go ahead with a question.
The question is, maybe if you can show us when you use the price indices and the volume indices to see the difference there.
Okay, so when you're looking at the volume indices, the difference, check on the formula for the, so this is so this one is for the price index, not the volume. So the formula for the price index is giving us the summation of P1 QO over summation of PO QO by 100%. So this is for the price index for aspires. Now let us check if you can see this one is for the price index, the formula. All right, that is when you're answering question 1A. For as long as you are taking that into consideration that 2022 is a base period, meaning that the quantities for 2022 is the QO and the price for 2022 is the PO. Then you finding the prices, we are using this is the formula to use on the price index. Now, on the volume index, okay, we are saying, which is part number B, volume index, the formula changes. It's a summation of Q1 PO over summation of QO PO. So the one which is going to be Q1 is the Q, not the P. So this is where the difference is. All right. Are we together there?
Let's go back to the price index. Maybe I copy there and I check.
Okay, so here you can copy this one. It's a summation of P1 QO over summation of PO QO. You can write that formula somewhere.
I've done that. Maybe we can go to the.
Let's go to the volume index now. It's this one here. So volume index for aspires index is summation of Q1 PO over summation of QO PO times 100. So let's say that's where the difference is.
Okay, thank you. I'm clear.
You are clear now, eh?
So this same applies to Pache.
This applies to this one for the partial index. The price index for the partial. So let's look at the partial index. Okay, so partial index. The formula for the partial index is this one for the price index. Okay, so for the price index for partial, this is for price. Now for the quantity index is totally different. Okay, it's almost the same though, but there's a slight difference. So here, this is for the price index. Okay, for the partial. Now let's go for the volume index. Okay, so this one you can write it somewhere. So you can copy this one somewhere for the partial index, the price index. Now getting down to the volume index.
That's 10.
Yes, please.
I'm sorry. I think I'm having challenges with the network. So I didn't think I was offline when maybe you may have been explaining the partial index, the one on question 1B. So I don't know if that's the one that you are about to explain now.
Yes,
because I wanted to also know on the volume, the differences on if there's volume indices and price indices.
okay, no problem. So we are now on part B of the question where we're looking at the volume index. Quite right, for the price index, this is a formula for per share. Okay, so I want to show you what the difference in the terms of formulas between the per share price index and the per share volume index. So this is the price index. So this formula, you can write it somewhere. Now the formula for the volume index is just slightly different from this one. So it's this one here for the quantity of volume index, is summation of Q1 P1 or summation of QO P1. So if you see here, it was the summation of PO Q1, but the one which is going to just almost the same, but what changes here is the P1, the P1 QO. Okay, so it will have this one QO P1. Okay, P1 QO. So it's almost the same, but what is going to happen at the bottom here, the one which is going to have a P1 is P1 QO. Okay, so we are going to have QO P1. Okay, I don't know if you've seen the difference.
Yes, we have.
The difference is just here, but the numerator is just the same, just that the arrangement is summation of Q1 P1 or summation of QO P1. This is it. So this is where the problem is. This is where the difference comes in. So we can now, but don't forget that this time around we are taking 2021 as a base. So meaning the quantities for 2021, prices for 2021 will be PO and QOs, these ones at this point. Then we'll be able to substitute there and then get the values that we need. So this is where we have the Q1 will be 2021, P1 will be 2020, this 2022 will be Q1, P1 will be 2022 because they're saying using 2021 as a base. So multiplying here Q1 to get the numerator, we are going to 2135.3827. Then getting down to the other one here, where we are finding now the QOP1, the denominator, QOP1. QO is 2021, P1 is 2022. Multiplying these, we are getting 278.27. Then after substituting here, we are getting 767.3779. Is that clear?
Yes, it is.
Yes. So this answers question one. Question one. So in question two, we are just sorting it out using 2021 as a base period. Okay. So initially, it was using 2022 as a base. So we are finding these three components. Okay. So finding the components of the aspires, the patch, and the Fisher using now 2021 as a base. So we are just doing almost the same, though we are just now using 2021 as a base. Okay, so we to go for the aspires index using the aspires price index using those ones. So meaning this one, it will now become as for 2022. It was just the examiner just needed to see the understanding. 2022, they're getting down to the other one, the QO, we are getting the 2021. All right, so this is about what is this one is going on. Then you can substitute here and get the values for each one of what we need. Then we are getting 278.27. All right, then the QOPO for the denominator here, we can get the 275.86. Then we can substitute here, and then we find a 100.87 on the last price index. All right. Then for the partial index, we are using this one is 2022 because we're using 2021 as a base. So this one will be 2022, just the opposite way. And this one is also 2022. So it's just a matter of multiplying these and getting that. So we are getting these figures here. And then the POQ1, this one, the PO is that of 2021. So 2021. And then this one is 2022. So this is how we are getting down to these values. All right. So this is the difference between the first one and the second one, where we are having these computations. So we're just substituting there, we are getting 101.743. This is on question number 2. Okay, so that ends question 2. Of course, we can even find the Fisher index, which was omitted. Maybe you can do the Fisher, so it can be incorporated. Fisher is just the Fisher index. You can put it here, where we are going to simply say it is just the square root of the last pi's index, and then multiplied by the partial index. Okay, so the last pi's index and the partial index on looking at these ones that we have. So unless there are questions so far.
So does it mean question 2 doesn't have B? Yellow.
It was okay. So now here question B has already been answered. We don't have to answer question B because question B has already been sorted out. Because question B, we are finding the volume indices because we are still using 2021 as a base. So the same answers, they are duplicated, you know, because we are still using 2021 as a base to compute the volume indices for last pi's. Because question 2 is saying using 2021 as a base period. So this one has already been answered. Okay. The one which we are supposed to be sorted out was the first part of question 1, because this one is already sorted out. I'm sure you get my concern there.
Yeah, now, I think that's very clear.
No, wait. Now on the question 2, where it says using 2021 as the base period. So if we go to question 1, there are two things. There's the price indices and the volume indices. So when they ask us like this, does it mean we are only substituting A on price indices? That's all. Then for B, we omit it.
The B one, we have already answered it because we are still, B was also correct, because unless B was using 2022 as a base, that's when we would have come to change it. Because here they're saying use 2021 as a base period. So meaning question number B has already been sorted out. So you just need to incorporate it there. I'm sure you've seen the rationale behind, not so.
Okay.
Yeah, unless this one, they said using 2022 as a base here, meaning we would have done all of it, or this one now, where you are looking at now 2021 as a base. So this one would have changed. But since this one has already been sorted out like this, then we have no option. We can just bring back the answers to question 2 for part B of this question 2. The part A, we will just do whatever we did here, except that we will change the base from 2022 to 2021. Is that clear?
Yes, it is clear. It is clear. Only that.
Yes. Yes. Okay. So this is the reason why we are sorting out. So we have this one. So we can find the Fisher index for this one. So Fisher index is actually going to be last pi's, and so this is number Roman numeral 3 of question 2, question 1, question 2, Roman numeral 1 is on the last pies. Then we have the Pache index, which is on Roman numeral 2. And then we can, so question 2A, we sort out this way, the way it is. For part B has already been answered in question 1, because we were using 2020. Okay, so 2020, 2021 as a base. So we have already answered that question. So here we can find the last pies index of 100.87. So we have 100, okay, 0.87, then multiplied by the other one is 101.743. So we can get the value here on the Fisher index of whatever we are computing here. So 100.87, okay, multiplied by 101.743. Then the square root answer, we are getting 101. So 101.30, okay, 0.3055. Okay. So this is about how we are getting question 2. All right, getting on the last pies index, the partial index, and the Fisher index, because part B has already been sorted out, where we are using for the quantity volume, where we are getting 2021 as a base. So we can still pick up these solutions, the ones which we have already calculated, because we have already found these ones. All right, I'm sure it is clear. All right, so we can now skip a little bit question 3. Let's go to question 5 on the assignment, because this one will come back to it a little time, because it's a theoretical question. Let's go to question 5 on the paper. All right, so question 5 is on time series. So this one is on time series. Okay, so we are getting this one on time series. So now what is going to happen here is we have the actual demand of a product for 8 months summarized as follows. So we have been given the month 1 through to month 8, and then we have the demand. So the demand there is 20.
Son,
Yes, please.
even last time on question 3, you skipped saying it's theoretical. We'll come back to it later.
Oh, okay. The reason why I want to do is because of the one now which has allocated to me up to 17. We are wanting to first of all sort out these quantitative ones, which are more cardinal, because the theoretical part we will discuss on sampling, because that one was on sampling. So I thought of first we'll finish up these ones, so that other one we'll be able to look at it in the next class. So because we only have about 20 minutes to go before the time that was allocated for 1 hour from 16 to 17. All right, so that one will be handled. There's no worry about it. Okay, so let's go to question 5. The actual demand of a product for 8 months are summarized as follows. So we have months 1 through to 8. Then the demand, we have 20, 26, 32, 44, 66, 88, 96, and 112. So they are saying find the 3 moving average. That's the first one. Then the other one, compute the forecast error. Then compute the mean square error, that's MSE. Then compute the mean absolute deviation, which is the MAD. And then getting down to B, the forecast of the product for the first week of July was 800, whereas the actual demand turned out to be 850. Forecast for the second week of July by assuming the smoothing constant. So using exponential smoothing. Okay, so this is on exponential forecasting that we are going to use. All right, so this is about how the question came. So we'll be able to get down into details of this problem. All right, so find the three moving average, compute the forecast error, then compute the mean square error, then getting down to computation of mean absolute deviation, then getting down to the mean square error and all that. So they can now get into the solutions right about now. So we have this one. Okay, so question 5, we have the three moving average. So what happens here is we are saying the three moving average. So we can get a calculator, you add 20 plus 26 plus 32. All right. And then the average of these three should go to the middle of the numbers. The average of the three should go to the middle of the numbers. So that's where we have the 26 coming in the middle of the three numbers. So if you can see, we have the 20 plus 26, then plus 32, then divide by 3, giving us 26. All right, so you skip the 20, you start adding from 26, getting down. So 26 plus 32 plus 44, then divide by 3, giving us 34. So you'll be skipping a number, getting down like that. So meaning to get the other one, it will be 32. Okay, 32 plus 44 plus 46. Then so 32 plus 44 plus 66. Then divide by 3 is 47.3. Just about that. All right. This is on how we are getting down to the moving average. The first component of the question 5, find the three moving average, which is 2 marks there. So that's how we get it. All right. So the three moving average, we are obtaining it using that method. All right. So now getting down to the other parameter. So the other parameter that we're getting down to is on the, okay. The other one we're getting down to is where we're looking at the forecast error. So what will be our forecast error? Okay. So we are getting down to this when finding the forecast error. We are going to subtract now. Okay. So we have the first one. Okay. So meaning the error here, the forecast error. So this is the observed value. Okay. Observed value. Okay, so this one should be revised because this one we are going to have observed value. Okay, so observed value. Then we can find the error here, forecast error. So these were forecast demand, then these are observed value. So this is the actual demand. This is the forecast. So this is the forecast using three moving average. So we have this forecast. All right. So we can find the error at each of these points. So the forecast error will be found. So that is the forecast. So we need to find the forecast error. So the first one is 0. The other one, yes, please.
So the observed value is what should be there where there's the error.
This is a demand. These are called observed demand. Okay, so these are called observed. And then where there's a three moving average, these are forecast. So this is the forecast.
Okay.
This is the forecast. Please take note of this. Please make those adjustments. So this is only the forecast. So make that adjustment, please. So we have that one as a forecast. So we can start finding. So these are forecasted value using the three moving. All right. Then we can now find the error. So what is our error here? Okay. So there is a slightly difference here on this computation. So these were forecasted. So the error there was what? 0. This one is -2. We are going to subtract 32 minus 34. The other one is 44 minus 47.3, which is -3.3, -3.3. I'm sure you're following that. Then this one is 0. Then the other one will be 88 minus
What are you subtracting to get those answers?
4.7. We are getting the observed minus the forecast. So we are simply saying the demand is observed demand, but we forecasted that our demand will be 26. So here there's this one minus the forecast. So demand minus forecast. So to find the error, it's demand minus forecast. So demand minus the forecast. We are together. So demand,
Yes.
demand minus what? Minus the forecast, minus the forecast. I'm sure we are together there, not so. Are we together there? So
Yes.
we can now get 96 minus the other one, 98.67. Which we have 2 points what? Negative 2 point what? 67. Are we together? So this is on how we are getting these values. Okay.
Then the last one, number 8.
So this one now, mean square error, we start squaring these ones here. So this one should be discarded, this one, you know about it. So mean square error, you start squaring these ones. So 0 square, okay. So mean square error will be just these ones, these errors, that's the mean square error. So you say 0 square, okay, so it will give us MSE. It will be MSE is actually equal to 0 square, then plus minus 2 in brackets square, then plus minus 3.3. Okay, you're following that square, then plus the 0, so 0 what square, then plus 4.7 square. Okay, all these squares. So meaning this one, there is no need to account for. Then plus negative 2.67 square. Then you divide by how many numbers they are. All right. So our mean square error would be, so we can do that way. So mean square error would be 0 square plus that square, the 2, negative 2 square, 3.3 square, 0 square, okay, then plus 4.7 square, then plus 2.67 square. All right, so meaning that we are going to have, okay, our MSE, so mean square error for that one is actually going to give us the total here that's given me 44.1089. Then we divide it by how many they are. Okay, so we need to count how many they are. How many are we seeing here? 1, 2, 3, 4, 5, 6. So we divide by 6. Okay, so divide by 6. So we can find the mean square error, which is 7.35. So 7.35. So this is the final answer on the MSE. Is that clear?
Yes, it's clear.
Okay, so that's how you get it, the mean square error. So we can now get down to the other component, the mean absolute deviation. Mean absolute deviation. So mean absolute deviation, you just ignore the negatives. So meaning these deviations that we are getting here on this one, these deviations that we are getting. So here, this is on this one now. So absolute deviation, we are getting the demand. So this one was corrected. So you have this one on page 17 and the forecast. So absolute deviation ignores the negative. All right. So this one is just okay because we have the zero here, deviation is zero. So meaning if it gives you a negative, you ignore it. Okay. So you have 0, 2, 3.3, 0, 4.7, 2.67. Just about these ones here are the ones that we get as absolute deviations. Then we divide by how many they are. So mean absolute deviation is 2.1167. All right, that's the mean absolute deviation. Okay. Now let's just get down to the last part of this paper so that you see thoroughly how these ones have been answered. Okay, from here up to here, they're getting down to the other one. The focus of the product for first week of July was 800 units, whereas the actual demand turned out to be 850. Focused for the second.
Then, sorry,
Yes.
on the compute the mean square error, there where you are drawing the table, does it mean the solutions we have, they need to be edited on that part?
Yes, that's why I'm doing, that's why I was telling you. So this is the month, this is the demand. So for the forecast, you put these ones. So the error is this column which I've incorporated here. So the difference between this one is what you should consider, not this one here at the bottom. This is the minor correction that we are doing on it. Eh? All right. Are we together there?
Yes, yes, yes.
So we are getting this is the observed demand and the forecast. So the error, we are subtracting these two to find the difference. So if it gives you a negative, pick it up the way it is. So, and then the mean square. So you square each of these values at a time. So 0 square, -2 square, -3.3 square, and divide by 6. Whatever you are getting, that is the mean square error. So that is why I introduced it this side to say mean square error here is equal to, after finding those squares at per time, dividing by 6, we are getting 7.35. So that is the mean square what? Error. All right. I'm sure you have understood on that one. You've gotten it.
Yes, understood.
Yeah. So now let's pick it up on the last one. So here we are looking at the MAD. For a MAD, is just this, okay, on this one, absolute deviation between these, so ignore the negatives. Okay, so now we are getting 2.11. Now this part B is on exponential smoothing. So this formula is on exponential smoothing. Okay, so exponential smoothing. So now under exponential smoothing, what it means is that we need to find the forecast for the next period based on historical data. So FT, this is FT1. This one is FT1. So here FT2 will depend on the odd forecast, which is meaning that for you to pass an exam, it will depend on if you have passed an exam before. So forecast for 2 will be forecast for 1 plus alpha, which in the question the examiner will give. AT is observed value minus FT1. So AT is observed value in that period, okay, minus FT1. So this is the forecast for a period, the alpha level. Then we have the observed value minus FT1. So meaning we are going to have, so here they're saying for the month, the first week of July was 800 units. Whereas the demand for that same week turned out to be 850. So this is the forecast. So this is the forecast for FT1. So our forecast for FT2 will depend on the odd forecast, which is FT1, okay? Then plus the alpha level, then what was observed, which is 80 minus FT1. So you just need to substitute here to find the forecast for second week. So forecast for week 2 is equal to the forecast for week 1, which is 800. All right. Then plus the alpha level is 0.25 Then the observed value for that week was 850. Okay, for the same week, which was observed value minus the forecasted value was 800. So this is about how we are getting to, this is the forecast. So the forecast for the second week, okay, will be just this one, which is 812.5. I'm sure it's clear unless otherwise. So our focus for week 2 will depend on the focus for 1, because I've given out, written here the how you get it. So 812.5. So this is the focus for week, okay, that's the focus for week number 2. So if you want to find the focus for week 3, as we are wrapping up, focus for week 3 will be based on focus for week 2, which is FT2, then plus the alpha level, then FT, which is observed value, minus FT2. So this is how we get the forecasting techniques based on part B of question 5, please. So this is how we found here, getting down to this one came as a build-up. The 0.25 is coming as a build-up. The 750 is there in the question. The FT2 is coming as a build-up. Substituting that, we got 796.875. The 750 was already given there in the question. All right, so we have the 750 here. So meaning that this is it, the forecast for week number 3 of that given question for the 3rd week of July. So the forecast, the actual observed value was 750. So there was need for us to find the forecasted value, where we are getting 796.875. So this marks the end of the question. So according to the time, it's 17 hours now. So we can end the class for now. So you just need to go through these solutions. If there are any concerns and queries, you can actually try to consult. We can actually get back to you. So you can end the class for now, unless there are further questions.
No question.